Functions. G of x is x minus 2 over 3 and f of x is 6x plus 8. There we have g of x. I imagine that we're going to use it first. To find g of a half, substitute a half in the place of x in the function g. So x is a half, so a half minus 2 over 3. It is not difficult to see that a half minus 2 is equal to negative 3 over 2, but we will look at that on a subsequent slide. So we have a half minus 2 to be subtracted from a half, and that is negative 3 over 2. The fraction may be reduced by a common factor of 3. This might be too big of a slice to swallow, but we will continue and demonstrate how simple this is on a subsequent slide. G of x is equal to x minus 2 over 3. In finding the composite function g of f of x, substitute f in the place of x in the function g. We are finding g of f of x. So g is operating on f. So g of x is x minus 2 over 3. G of f is f minus 2 over 3. That is always a good initial step to take in composing functions, because the common mistake that students make is that when composing functions they substitute the wrong function into the other. But by saying g of x is x minus 2 over 3 and g of f is f minus 2 over 3, then we have guarded against such a mistake, and we have an initial step that demonstrates that we know exactly what we are doing. Next, replace the occurrence of f with its algebraic representation. So where we see f, we put the algebraic representation of f. What is f? 6x plus 8. Put that in there. 6x plus 8 minus 2 all over 3. 6x plus 8 minus 2 over 3. Positive 8 minus 2 is positive 6. So we have 6x plus 6 divided by 3. And we may simplify that by taking a common factor of 3 in the numerator. Taking a common factor of 3, what do we have? 3 open bracket 2x plus 2. 3 open bracket 2x plus 2. And that we will divide by 3. When we do that, what do we know? 3 cancels 3, and we have 2x plus 2. The fraction may consequently be reduced by a common factor of 3. The 3's are gone. G of f is 2x plus 2. Now we will take a look at the manipulation of the fractions. A half minus 2. In simplifying that arithmetic expression, let us consider that 2 may also be written as a fraction as 2 over 1. So replace 2 with 2 over 1. What do we do next? The common denominator is 2. Remember that multiplying the numerator and denominator of a fraction by the same number does not change its value. So multiply both numerator and denominator by 2 in order that the denominator can be 2. But what will happen? The numerator will be 4. So we have 1 over 2 minus 4 over 2. The denominators are the same. We will just simplify by manipulating the numerators. 1 minus 4 is negative 3. So negative 3 over 2, and we have simplified that. Now we will divide negative 3 over 2 by 3 and see what happens. Let us see how the expression may be reduced. We know that a fraction bar means division. Let us replace the fraction bar with a division sign. So 3 over 2 divide by 3. Negative 3 over 2 divide by 3. That's nice. Then what do? Go ahead again and say that dividing by a number is the same as multiplying by its reciprocal. And the reciprocal of 3 is 1 over 3. So we have negative 3 over 2 multiplied by 1 over 3. Then the fractions may be reduced by a common factor of 3, as we can see, and the answer is a negative a half. Right. So we have negative a half right there. Is the result? There's no difficulty seeing how we arrived at it. G of f is equal to 6x plus 6 divided by 3. We reduce the fraction by a common factor of 3. For our basic fractions, we cannot reduce them unless we have a common factor. We choose to factorize the numerator. That was not a necessity, as long as the step implies that we are making use of a common factor in the numerator. So from our basic fractions, we cannot reduce them unless we have a factor that is common to both numerator and denominator. And the same thing applies to this algebraic fraction. Cannot reduce unless we have a common factor in the numerator and denominator. In this particular case, the common factor is 3. Now, we did not need to factorize as long as the step that we are taking is suggesting that we are making use of a common factor that exists in both numerator and denominator. F of x is 6x plus 8. One method of finding the inverse of a function is to take the function, say f, substitute x for f of x and f of x for x. That we will do 100 times. Also, since in the end the expression that we will find is actually the inverse of the function f, it is more appropriate to have f inverse rather than f in the expression. So we have x is equal to 6f of x plus 8. But when we transpose this, making the subject of the formula, the expression that we would have found is the inverse of the function. So it is more appropriate to write f inverse right there rather than f of x. We may now transpose the formula, making f inverse of x the subject, the first step of which is eliminating the positive 8 from the right hand side. So x minus 8 is equal to 6f inverse of x. Then we need to finish up by eliminating the 6, dividing by 6 on the left hand side. It is more appropriate to write the inverse of the function on the left hand side, so let us turn this around. And that is our answer. I love this problem because life can be made easy if we use the grid judiciously. Write the coordinates of A and B. That's not difficult. For A, what do we have? For A, move 2 units in the negative x direction, and then we will move 3 units in the positive y direction. Negative 2, 3. For B, we will move 4 units in the positive x direction, followed by 6 units in the positive y direction. 4, 6. The presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. The presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. The gradient of a line tells us how steep it is. That is, how much it goes up as it goes across. This may be simplified to say y difference over x difference, change in y over change in x, or rise over run. Instead of using our usual formula, which is the gradient is y2 minus y1 over x2 minus x1, we may choose any 2 points on the line and see how much we go across as we go up. So instead of taking the 2 points that we have here and finding the gradient by saying 6 minus 3 over 4 minus negative 2, then we have another approach that we may take by using the appearance of the line segment on the grid. We may choose the horizontal movement to be 1. If we choose the horizontal movement to be 1, this will simplify our calculation because we will be dividing by 1. Do not forget that is what? Vertical difference over horizontal difference. So if we divide by the horizontal difference of 1, then we know that whatever we have for the vertical movement, that will be the answer, because anything divided by 1 is equal to that same thing. So we use 1. So we start here, we go across 1 unit. So 1 goes there. Then we go up. Notice that by the time we are going up, that's just half of a unit from 4 to 5. That's halfway up. So that is half of a unit. So we go up by half of a unit, like so. M is a half over 1. Anything divided by 1 is that same thing. Therefore, the gradient is equal to a half. As stated before, the presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. This fact may be extended to determining the equation of the line. The general form of the equation of a straight line is y is equal to mx plus c. M is the gradient that we have calculated on the previous slide, and c is the y-intercept, where the line crosses the y-axis, which is at 4. Let us write the equation of the line, substituting the value of m is equal to a half as we have calculated, and the value of c is equal to 4 as we see on the grid in their respective places. Y equal mx plus c. M is the gradient that we have found to be a half, and c is the y-intercept that is equal to 4. So y is equal to a half of x plus 4, and that's all there is to it. The examiners are expecting the alert candidate to see the simplicity in the problem that is afforded by the presence of the grid. Nevertheless, they will not be alarmed by those who choose to use the formula in making their calculations. The former is not a shortcut, but making use of a glorious opportunity. So we are making use of a glorious opportunity, that one that is afforded to us by the presence of the line on the grid, by which we can just use a little segment of it in order to determine the gradient, and also make use of the fact that this is the y-intercept.